So how many people usually dial in?
Yep, I think we're good to go. So
Nice.
so Deniz, yeah, thanks a lot for joining us today as well. So just want to give a small introduction to the episode for everyone who's watching. The core idea for this episode is reinforcement learning and environments in the real world. The big shift in AI at the moment, as I'm sure some can see, is that models are moving from simply answering questions to actually kind of taking actions. Once AI starts acting, it needs somewhere to practice, like fail safely, kind of get feedback and improve. And for today's kind of conversation, I've got Deniz from Fleet AI. So thanks a lot for Deniz for joining us. Really appreciate that as well. We're going to kind of get into some of the topics here as well. Talking about obviously Deniz's background, but then talking about reinforcement learning with agents in general, kind of like training gyms also as well. So some of the things we're going to unpack in general, how agents learn through practice, like why environments like may matter, how feedback and reward shape behavior, and why better training worlds kind of will lead to making AI more reliable just in general. So Deniz, obviously who's joining us, I want to thank you for obviously being with us today. I want to start with some of your backgrounds, obviously giving some of our viewers some information as to obviously who you are and obviously why you're kind of talking about agents and reinforcement learning as well. If you could give us a bit of a quick background on yourself, that'd be super appreciated.
Sounds great. Yeah, thanks for having me. So yeah, nice to meet you, everybody. I have been working in like a ML like research space for last maybe like 10 to 15 years, like across different like startups. The roles change, but so idea is like around sort of like applied research and like research. And a little bit about yeah.
Okay, carry on. Sorry.
Oh, and a little bit. I was just gonna a little bit about Fleet. And the Fleet is now I'm currently a research engineer Fleet, and at Fleet we we are a RL environment startup, and we work with frontier labs and provide them environments.
Great. Thank you, Deniz, as well. Before we kind of get into some of the Fleet work and kind of your experience with like agents and reinforcement learning as well, that you've got a great career so far, and obviously you're working at obviously a really interesting startup, like a frontier-esque startup at the moment as well. What led you to? Have you always been interested in artificial intelligence and reinforcement learning? I guess these concepts are kind of like old but new in some regards as well in commercial aspect. Like what kind of brought us here today?
Yeah, I mean, yeah, you're never late to get into it. In my case, it was around 2011, 2012. So where like data science was like just becoming more and more popular. And I was in finance. I was like working at a hedge fund, and I thought like that path will be more intellectually rewarding and challenging. So I just like took some time off and jumped onto like data science things.
Yeah, is there quite a strong crossover with? I see a lot of people from like hedge funds and like finance moving into kind of machine learning. I guess the strong stats math background. There's a lot of kind of crossovers there.
Yes.
What had you worked with agents like before, kind of working with Fleet is as well, or is this I know that the year of the agents was 2025, right? So many companies kind of moved in that direction. But these obviously hasn't been around for super long. What was your kind of first interaction with agents, and again, has it massively multiplied your experience doing it at Fleet too?
Yeah, that's an interesting question. I think in my like line of work, which is sort of like research engineering and like software engineering in general, right? I think these things like start working not too long ago, maybe 6 months ago. So like I think that's when I started like incorporating these tools like earnest in my workflow.
Okay, and I guess for someone who kind of hasn't heard of Fleet before as well, I know you kind of mentioned some of the things that they do. How would you explain like who the company is and potentially like what the mission is with you guys?
Yes. Yes, we are an like environment startup. We study environments, and we build environments. Environments shape the way the models learn and interact with the model. So, like for us, it's important to understand like where the like frontier model failures are, and like build like environments around them, and like measure those like learnability that is coming through the environments.
Interesting. And I think with the environment piece is as well, that's quite a new concept for many people in this space who kind of work on the periphery, because I think a lot of people may have heard of agents before, but not so much on the environment piece is as well. So I think we're going to get into some of that today,
Mhm.
which is great. Now, I think one of the aspects that we wanted to talk about is reinforcement learning,
Sure.
specifically for agents as well. And I kind of start because we've got a bit of a mixed audience today. There's obviously some like more engineering focused people, some more machine learning
Mhm.
focused people, some people who just are around in the AI space in general. So I wanted to start by making reinforcement learning simple. But the way
Sure.
that I understand it, like reinforcement learning is about an AI system learning from experience, right?
Yes.
So this is from my understanding. It tries something, it sees the outcome, it gets feedback, and it gradually learns from kind of which actions
Sure.
work better. So, like, I guess from someone who's obviously working in the space rather than obviously around it, how like what does reinforcement learning mean in plain English when we talk about modern AI agents as well?
Yeah, I think you're spot on. It is like RL is the reinforcement learning is the paradigm where a model learns from its own behavior
Mm,
against the rewards,
mm,
instead of say like mimicking a teacher or a fixed data set.
mm,
And the way to maybe think about it on a higher level, you can think that imitation has a ceiling. When you train your models against a fixed data set, your model is going to be as good as like the process like what process produced that model. But in a
mm,
like high level, like RL has no ceiling practically, right? Like only there's
mm.
an environment and there's a reward, and the model interacts with the environments and like learns from that experience.
Got you. So I guess that the key difference is that you like you say the agents learn through like action, not
Correct.
just examples. So if by doing the task, um, they kind of go through and improve
Th-
self improve
that
somewhat.
that is
Oh, I think we just lost
software,
Deniz.
or
Uh,
like a website. So the model is given a task, and it just like takes multiple steps, um, and at the end it gets some sort of like a like reward, and then it
okay.
learns from that like reward, and it just like next time hopefully it just like does better and like hill climbs through that reward.
Mm. and and I think for some people who are even less, they might see like words and different concepts as well. For those people, just breaking it down from a very high level, what would be the difference between like a model
Mhm,
and an agent? Like for
mhm.
example, how do we split the difference between that?
uh yeah, that's I I think I think it is the same thing more or less, but I mean agentic
Mm,
workflows more stand um, for like multi-step sort of like behavior,
mm,
right? Like so like as in the model has like more like agency. It can go and like operate in like real world and like take some actions, and like complete a task.
mm,
And the
yeah.
model, and these agentic systems, if you will, like agentic systems might have like multiple components in them, right? Like the agentic systems
Mm,
might have what they call a harness, which glues like everything together. It might have like memory components, so on and so forth. And the model is like one of the components, well, important
mm,
components in the agentic system.
mm. So some differences, some like some definite crossovers with those kind of terms as well. So same but different. It's in some regards as well. So thank you. I think what I wanted to kind of move the topic to was talking about the environment kind of side as
Sure.
well, because obviously that is important for the work that you're
Mhm.
doing at Fleet as well, and why they are so important in general. I guess in the real world, work is messy. It's not sterile. It's not static. It's always dynamic and moving, and things go right and things go massively wrong, like a lot of the time as well. So tools can behave like very unexpectedly. Information could be like missing, and there always are edge cases, right, as well. So I guess if we want agents to operate in real workflows, they need training environments that mimic real life and not just a sterile demo of or a sterile situation. So I think in robotics,
Mhm.
taking that for example, people talk about simulating to a real
Mhm.
problem,
Mhm.
something that works in a simulation but struggles with the real world. But I guess there is a version of that or something that's akin in when we're talking about AI agents as a whole as well. So I guess
Yes.
look, why do like AI agents need realistic environments before they're used in the real world? Is there any use cases where you just do a sterile demo, or does it all, or the best cases always something that's really simulated with lots of messy like environments in general?
Yeah. Um, yeah. That's a good question. Like a right analogy with robotics. Like just like describe what an environment is. I think just first of all, right? Like the starter kit of like environments is like often like some sort of software, and the model or the agent learns how to finish certain tasks interacting with that software, and even more concretely, that can be like enterprise software, like any sort of like the software you use at work, like could be like a Jira or could be like anything, right? Could be expense management, or the consumer software. It could be Google Maps, it could be like whatnot, whatever you're really using in your daily life. And the environments are like uh, simulations or copies of that like real life software, where the model is given a task and the model learns like how to finish that task within that environment. And to yes, and you're right that there's like some sort of like a sim to real gap there as well, right? Like the environment, the copy of environment you produced might differ from the actual environment. But as the models get better, they get more robust. Like they can transfer what they learned in a simulated environment onto real world.
Wonderful. And what makes an environment realistic,
Hmm.
rather than just another test, do you think?
The realism. I think. I mean, I think to the extent it mimics the real world, right? And with the environments, essentially, again, it's just like a sort of like the copy of software, and with some tools attached to the environment, and the model interacts with the environment through the tools, right? And like
Okay.
tools is like what the model sees and what the model has access to, and to the extent that the tools like corresponds to sort of like real life tools, and the parameters correspond to real life, sort of like the real life use cases. So the model should be able to like transfer the knowledge from simulated environment to real life environment, real life
Okay.
like use case.
And interesting. I mean, how do you make sure that the agent is actually learning behavior that does transfer into real workflows? Is there a way of kind of figure what's the best way to figure that out?
Yeah, that's a good question. I mean, the one way to do this is like obviously like train on your own environments, and then see how well it transfers to the environments that you're targeting, right? Like sort of
Oh,
this is like if RL is has like two sides, one is the model side and one is the environment side. you can like train your own model against the environment you built, and like see how the behavior of your model has changed like after being post trained on the environment.
Interesting. And I guess that leads us quite nicely to the next point, which is like how Fleet is actually thinking about training gyms, like specifically. And I guess
Hmm.
that's where it gets really interesting, right? So
Hmm.
uh, a training gym makes the idea easier to understand. It's not just a test. It's a place where like agents can practice like real tasks, deal with like realistic scenarios, and improve before it would hit any kind of live situation or live workflow, right? And so in AI, people talk a lot about models, and Fleet seem to be focused on the world around the model, the tasks, the environment, the feedback, the evals, and the human supervision. So when Fleet talks about
Hmm.
training gyms for agents, to you, what does that actually mean?
Right. The training gyms are, I mean, I think it's what we sort of like what we already like touched upon, right? Like these like
Mm,
you can't think of it as in like multiple directions. Like
mm,
one way to think about it is just a really copy of software. And
mm,
the like we have the Fleet, as a company, we have a scalable backend, and and the labs can run their mo- mo- do their training runs against our backend, and like scale that up, right? Like sort of like they
right,
can
okay.
like spin up like hundreds and like thousands of like instances of that environment, and the model like tries to solve that, like solve a given problem in that particular instance. Copy of software to one way to think about it, and there are other ways to think about it, right? Like that it doesn't it's not just copy of software or software the agents interact with. You can think of as sort of like a file system, like environments, similar
Mm,
to basically like how you will interact with your computer, right? Like you have,
mm,
and it became like one concrete example is like these like claw style environments, where the agent has access to your like local file system, and that can be many things, right? Like that can be like spreadsheets, that can be like PDFs and like whatnot. And then again, like it's just given a task. Maybe it's a financial analyst task. Like you have like bunch of like again like documents, and you ask the model, hey, do a like a discounted cash flow analysis,
mm,
and the model sort of like given access to the file system, and it tries to accomplish like a given task. And
mm,
at the end of the trajectory, at the end of the interaction, the model like receives like a feedback or a reward. So the
yeah.
reward part is like sort of the critical part. Like the environment gym is always like the interaction ends with the reward, and that's like how the model like learns from.
Yeah, interesting. And I think that leads us to our next point quite nicely because
Mhm.
that's a key way. That's the key way
Mhm.
that agents actually improve, right? With reinforcement learning is
Mhm.
through this reward system.
Sure. Right.
Like when an agent tries something, gets his feedback, learns from the result. But in the real world, defining success is not always as simple as that, right? Um, so I'm interested to explore kind of with you. Um, I guess like what a reward for us is very different. Like if I
Yes.
if I do a task and I get a reward, get some well, it might be the same thing, right? It could be some praise from my boss, or it could be like going and treating myself with a drink or going to a nice
Yes.
restaurant or something like that. What does a reward for like an agent look like? Is it praise? What do they constitute as like something like that for them, which reinforces to them to do that multiplied right in that or a learned behavior?
Yeah, that's a, I mean, that's a very like a deep question, right? Like there's I just remember like listening to like Ilya's podcast, and the interview he gave, and he was saying that the humans like have a pretty good reward system, right? Like
Mm,
when you do something, you know what, if it's right or wrong, more or less. It's kind of like encoded in you, like it's part of the evolution. um but the models don't necessarily have a very good like reward system. At least like we haven't in the industry hasn't gotten there yet. So in lieu of that, like we have to like each environment sort of like comes with a sort of like reward like function. um, and that's a very sort of like very active like field of research. um, and it's important to like important to like to make the distinction that it's like proxy rewards, right? Like there's always like sort of like the pitfalls around it. Like the rewards that you think is best to learn from might not be the actually like the true objective. And I'll give you like another example. There's like really like now like famous a Coast Runners game, I think, like from 10 years ago, when these like are all environments, sort of like first sort of like people started like learning from them, like at scale. Uh, the canonical example is like this boat figured out a way to kind of collect rewards without like finishing the game. It just like kept like looping around like some sort of like local sort of like the area to kind of like harness reward. But so that's kind of like an example, right? Like the actual true objective is finishing the game, but the model figured out, oh, maybe I'll just like do this the entire time and just like collect a lot of rewards. Like this is like what I care about anyways. So that's like one distinction. Um, but if you set a reward, right, like so there are multiple ways to go about it. You can do it like programmatically. You can if you think about it, right, like if the state of your environment is maybe represented by a database, um, your a website, you're a shopping website. um, the shopping websites are generally backed by a database, right? Like sort of at the end of the trajectory, you can like check the state of the database. You can say, oh, has the model ordered like two pair of shoes, like black and like size like 8, and it's like under $100 and like sent to like it's going to be shipped to the right address. So that's like programmatically defining what success will look like is like one way of doing this, and which is a valid way. Um, Ultimately, however, like as the trajectories get longer and longer, um, imagine, right? Like you sort of like work on something for like hours at an end, and at the end, like you either say like it gets a thumbs up and thumbs down. That's like a very sparse feedback for you to like learn from. Like ideally, you want to be given sort of like a more obviously like right like more sort of like feedback, and that's again like sort of like a pretty active active sort of like research area, because like that also like leads to sort of like reward hacking. Defining the right like sort of like the criteria is like sort of like super critical for these models to learn more effectively.
Would you I think you mentioned just before, but again, when that agent found this kind of loop, and I just want to collect all the rewards. That's what I think is best thing in this situation. Have you seen? I've seen things previously, like physics simulators, where they put like I can't remember these like characters in a room, and they learn how to break out the room. They learn how to break the simulation in a way that they'd like. When they do behaviors that are unexpected and make shortcuts, is that behavior like rewarded to find it like a much easier solution, or does it depend on the, I guess it depends on the situation?
The so just you're cut off a little bit. Are you asking like how do you catch these sort of like the less than like in like a not intended sort of like.
Yeah, if it was like if an agent found like a shortcut,
Sure.
is that behavior rewarded?
Hmm.
Um or is it always rewarded, or does it depend on the context of how they cut the shortcut?
I mean, I think so. If I understand your question correctly, it that solely depends on the reward structure you defined,
Mm, okay.
right? And I
Interesting.
mean, hence it's just like very critical to like work on the shape of reward the model receives.
Mm, okay. And I guess like how important is a human feedback in shaping what the agent learns is as well? Is there like always is there different situations where there's a human in the loop uh,
Right.
to a higher degree, and is there some situations where it's needed far less?
Mhm.
I'm interested to understand that.
Yeah, I mean, yeah, that's a good question. Sort of like these like programmable rewards come are useful and are um they can be like hill climbed on in verifiable, what they call like verifiable environments, where it is easy to verify the solution, right? Like it can be like sort of like a math example, it can be again like a shopping example. The common thread here is like it's the task might be hard, but it's easy to verify the solution. There are cases where it's not easy to verify the solution. um, like canonical example is like the learning from like human feedback, right? Like sort of like you're a chatbot. It's again like canonical example. Like how do you determine whether chatbots like the response A or B did better?
Mm,
So that's a very sort of like multi-dimensional question. That's
mm.
when sort of like usually like human feedback like comes in, which is kind of like things that are like much harder to verify.
Yeah, yeah, for sure. And it's interesting the role that we play now, and obviously there's so much in and noise out there about AI taking over jobs. What's the replacement we can see at the moment? I feel this year it's a big shift in people going, oh, this could be massively impactful to the area that I'm in. It may not be this year, but I can definitely see the trajectory that we're on. I
Mhm.
think this is the first year that I've actually seen a shift in maybe some perception in many industries, I would say as well. But that kind of leads us to more of a question. I even speak to engineers who are like working with a lot of agents as well, like teams of coding agents, right? And I feel like what's the future role of like where humans fit in to all of this? So I guess my first question: do you think like humans are becoming more like coaches or like reviewers or managers of AI agents? Do you think that's the kind of task that the role that we'll be playing in the future is just managing lots of processes, giving the rewards and the thumbs up or the thumbs down, and making sure
Yeah.
things don't go massively wrong or off
Y-
track?
Yeah. Um, yeah. I mean, I think that's a difficult question. The way I can like draw analogy from my work is it's a like higher level like work, right? Like sort of like a software engineering. You don't necessarily know the you don't necessarily look at the code anymore.
Mm,
You don't
yeah.
necessarily sort of like need to name the class um and like make those like sort of like lower level decisions, but it's your responsibility to like understand like what you want the model to do, what the like success criteria looks like,
Mm,
and manage the model, right? Like it could, because like still these models can just like go off the rails like quite often. So I think like importance of understanding and like knowing the domain or your sort of like specialization doesn't is not gonna go away. But it's
mm,
just like you're doing your work like on a sort of like higher level
mm.
to the point. Yes, like you're sort of like a more and more sort of like acting like a manager.
Yeah, I could team leads. I think I spoke to someone uh, the other day, and they were saying to me, they have 20 agents kind of working for him, and he can be. He's like, well, I can be as blunt as I want with my feedback to my team because they won't get as if I say their code is rubbish or whatever, they won't get as
Yeah.
feel as bad about the feedback that I give them as well, and I take it on the chin as
the,
well. And
yeah, I mean, I always like try to be nice.
yeah,
I always like still say my pleases and like thank yous.
yeah,
I think there is a like optimal level of parallelization in your workflow.
mm,
Like I think some people definitely have more than others, but it's also, I don't think it's optimal to work with like tons of like agents because you
Yeah.
still need to sort of like have a like very good like mental model like what you're trying to
Yep.
do there. Like at least like me, if I have like more than like 4 or 5 Claude agents, like I'm kind of like I start getting like little doozy, and like
Yeah,
miss
for
context.
for sure. And I think, I mean, I've been like a hands-on like manager before as well, and I think that if that's the role that you're playing, even how many ICs, even if that are humans on your team, can you effectively manage before you're going completely hands off into a more strategic role, right? So I feel like where the agents are doing 10x the amount of code as well, and like you say, it's quite interesting because this interview 5 years ago, like someone will be scratching their head when in 5 years time we're going to have Deniz on and he's going to say I don't even look at the code that the agents are writing. So it's crazy that the kind of world that we're living in as well. But yeah, the role of engineers it is changing and it will change, and it'll be interesting to where we are in 2 or 3 years. And not just, I don't feel it's just the role of engineers, but it's other people's like career trajectories I think will change off the back of it as well, that are being moved into more technical environments, I think, is as well. And I guess like, I think I guess one of the things that we want to maybe cover kind of last is that is the reliability, right, as well, because I think that's really really important when it comes to like these agents as well, because there must be like a lot of working critical environments sometimes where these agents must be highly reliable as well. So I guess I think a lot of people, I think it's that trust issue where I think we're at this level at the moment where I feel like we're on the precipice of something. There's a lot going wrong still, but there is a degree of we can see the light at the end of the tunnel, and the failure rates will lessen and lessen and lessen. What should companies look for before trusting an agent in a real workflow? And I think that's will be a kind of key question for many people kind of watching as well.
Interesting. Um, I don't like there's a sort of like safety critical environments, right?
Mm.
It's like in like sort of physical space, like self-driving
Yep.
cars and so on and so forth. I don't have a like a very good sort of mental map for it.
Mm.
I haven't like worked out in those like problems. So
Mm.
it is like yeah like harder for me to sort of kind of like give a like educated answer.
Yeah.
Um I mean like that's like partly right, like partly the simulation environments like exists because you don't necessarily want to learn in like real life, like from like real life experience, because they're costly and like they can be also like harmful, like they're like safety concerns. So that's like mostly why you train these models in like sort of like these like simulation environments.
Yeah. Mm. I feel like we're in again quite an interesting time where there's probably a lot of companies feeling like fear of missing out, and
Mhm.
I'm sure there'll be many examples over the next few years
Mhm.
of people deploying agents in their business, and as a result of being too early or not being simulated and not being reliable enough, and some bonkers things happening as well, which is kind of scary given what kind of bit for some insurance business, healthcare business, it has massive implications, right, on what can happen in the real world. So I feel that lots of mistakes are going to be made,
Yes.
unfortunately, in the real world
Y- y-
before we get to the optimal solution.
yes, I mean there was like there was like news like this week that like a company that shall not be named spent like a 500 ran up like a $500 million like
Yep.
entropic bill. um
Yep.
yeah. That
It,
can that's like one of the sort of like more extreme examples, but yes.
yeah, I mean, it's a really good example to give because that is we say these numbers and it's like it doesn't even make any sense for us because it's just we can't even begin to imagine like a number that big being spent on compute in probably such a small amount of time as well. But yeah, I think that's a really good example, and I'm sure it won't be the last as well. So I think that covers a lot of kind of thing what we wanted to cover today. So I really appreciate it. So I think I want to bring this back kind of to conclude to the kind of the bigger picture. Like we started with like reinforcement learning, but like we talked about, the real world isn't just about kind of static environments like research demos. It's about teaching agents how to act in like reliable, like practical and somewhat messy environments. Now, what you guys are doing at Fleet seems to be obviously truly useful. Like if the agents are going to be truly useful, they need more than just powerful models, right? It's not just a problem of like scale and compute. They need really good practice, good feedback, careful evaluation, and environments that prepare them for a real world. And I think that's so important to where we're headed, because I think people just think of scale, compute, throwing everything they can at that issue, but this seems to be the core. I'm going to say like infrastructure layer behind like agentic work being a real success. That the practice behind it as well. So I guess one final question: if there's one thing people should understand, if you're gonna anything to add else about what you've said so far, then is if there's one thing people should understand about AI environments and agent training, what do you think that one thing should be?
Maybe like we can talk about like a little bit like where it's going. The like the setup that we described so far, it's like emulating real life workflows, right? And pretend that like he or she's an analyst and like try to solve a problem or like set up a problem, right? This has worked so far, right? Like you can see from the like model capabilities, like hill climbing constantly. There's like a lot of data to be unlocked. Having the models actually like learn from the real life experiences. And like that at Fleet, sort of like we're making progress like on that front as well. But essentially, like, can we capture the like real life workflows, and like learn from them, which is kind of like a massive like value unlocked. And I believe like that's where sort of like where the like industry is like heading a little bit.
Interesting. I don't think it's too far. We are away from those things as well. I think you're totally right
Yeah,
as
like
well.
everybody's going to be wearing something on their top of their head, and like while they do work. And it's happening
Well,
at large companies already, right? Like as you know.
well, we've heard a lot of rumors about Meta and
Right,
obviously their new teams, and there's a lot of uncertainty.
right.
We've heard from a lot of people that work there as well. So, and I'm sure they're not alone in some of that is as well. But yeah, totally right there. Well, this has been a really useful way to think about the future of agents, and that is actually a really good way to wrap things up. And my takeaway is agents don't need to be smart. They need practice, feedback, and really strong environments so they can become reliable in the real world. And that's what Fleet is really trying to assist with as well. So Deniz, I think we're going to take a few questions, but I just want to say thank you very much, obviously, for joining me today. It's been really insightful, and I hope, obviously, I'm hoping it's obviously provided a lot of value to our audience as well. I think we've got a question actually, and anyone else feel free to kind of chip in and ask a question for Deniz while he's here as well. But a question from Arayan on LinkedIn. I think he's wants to ask you, Deniz, could you walk us through a scenario where you had to integrate an AI agent into an existing client workflow? Like handling edge cases where the agent produces inconsistent or hallucinated outputs in a production environment, and how your team detected, flagged, and resolved it as well.
Mm-hmm. Uh, yeah, like that's that I think that pertains to like the deployment to actual like real life like workflows. As a
Mm,
fleet, as a company, that's not our domain. We don't like deploy like agents to like real like enterprise like the we don't do like enterprise deployments, if you will. But the way I can like maybe answer the question is we often try to come up with sort of like interesting and like challenging tasks like for these models. And then like I don't have an example on top of my mind, but there's like always cases where the model solves a problem in a way that's you don't want it to solve, right? Like sometimes like sort of like it hacks, like sort of like maybe the here like canonical example is maybe actually the data is like available or the solution is available in the file system, and like tries to access to that file system, like so on and so forth. I think giving like a understanding that the understanding the behavior of the agents is critical. Like we do a lot of work on the oversight front. um, um, it as a responsible sort of like the parent, if you will, like you want the agent to like learn like the right way.
Awesome. Well, I think that was one of the questions that the kind of chat had for us as well. But thank you, Deniz, for your time today as well. And if you missed any of the episodes, it will be available on LinkedIn as well. We'll be providing some clips to everyone from Deniz's answers. But again, I just want to say a big thank you to Deniz for obviously spending some time with us, talking us through like his background, like his thoughts on RL. And agents and training gyms at Fleet. And yeah, thanks a lot for joining us, Deniz, and everyone kind of watching as well.
Thank you.
Awesome. Thank you. Cheers, Deniz.
Bye.